Hello, 7th graders. Welcome to Lesson 4-3, Multiplying and Dividing Monomials, found on page 187. Now, we are going to learn how to multiply monomials and how to divide monomials. You're probably wondering already, what is a monomial? Well, as you can see in your book, a monomial is a number or a variable. A variable is what we mean when we say a letter, okay? Or a product of numbers. Product of numbers meaning when you multiply a couple of numbers, the number that you get is the product, right? A product of numbers and or variables. For example, 80, a number, a whole number on its own, is a monomial. The variable x, a number that we don't know the value to, is a monomial. Or a number that we don't know times 8 times a variable is a monomial. What is not a monomial is when you add a variable plus a number, or you have a variable squared minus another variable squared. These are not monomials, okay? These are, equations that you can, or number sentences. So here is an example of a monomial. Got it? Now, a key concept for today. When we multiply powers, okay, with the same base, as you can see here, we add the exponents. So for example, you have 2 to the power of 4 times 3 to the power of 3 times 2 to the power of 3. We actually add the exponents, so it's 4 plus 3 equals 2 to the power of 7. Makes sense, right? Because really what you have is this. 2 to the power of 4 is 2 times 2 times 2 times 2, but we're going to continue to multiply. We're going to multiply another 3 of them. So really what we're doing now is 1, 2, and 3. So in reality, we have 1, 2, 3, 4, 5, 6, 7. We have 2 to the power of 7. Make sense? Look at example 1. We have a base of 4, okay, on both sides, and we have the exponent of 3 and the exponent of 5. So we just add them, and we have 4 to the power of 8. Here we have 6 to the power of 1, really, but we don't put the 1, and then 6 to the power of negative 4. We work with these as if we were working with integers, adding integers. So when we have 1 plus negative 4, we're going to have negative 3. And there you go. It's 6 to the power of negative 3, or you can place it as 1 over 6 to the power of 3, just like we did the last lesson. So here we have 1a and 1b. Go ahead, pause the video, try these two on your own based on the examples we just looked at, and then play the video so that you can see the answers. Okay, pause now. Alright, I hope you paused the video. Here we have 5, our base of 5, and we're multiplying them, so we just add the exponents. 2 plus 3 equals 5. So it's 5 to the power of 5. And over here we have our base, for b we have the base of 12, so we know it's going to be 12. And now we have 3 plus negative 2. 3 plus negative 2 is going to be to the power of 1, or we can just simply say 12. If you look at example 2, you'll see that we can do the exact same thing now with the variable, as long as it continues to be the same variable. Here we have the variable b, and we have 2 plus 2, so it's b to the power of 4. We can also do it with t, the same base. We have negative 5 plus 3, it's going to be negative 2, as you can see right there, right? Let's try that with these 4. Again, pause the video now, and then play again to check your answers. Pause now. Okay, so we have the same base. We have, for 2a, we have y, okay, and then we have 6 plus 3. It's y to the power of 9. For b, we have r as our base, and now we have 6 plus negative 5. It's just going to be r to the power of 1, right? We just keep it as r. For c, we have 7 plus 6 is going to be c to the power of 13. And for 2d, x, base of x, we have negative 6 times, when it's multiplication, we add it, plus 2 is going to be to the negative 4th power. You can also write it as 1 over x to the 4th power, right? Okay, now let's look at example 3. Things are starting to get a little more complicated, but at the same time, I actually think it's a little more fun because you're now dealing with multiple areas. Here we have 2x to the power of 3 times 8x to the power of 4. We're going to use commutative property of multiplication, and we're going to put together the variables and the numbers that are able to work together. Really what we're doing is we're going to simplify this entire operation here and convert it into 1. So the way it works is, if you actually take a look carefully, we're going to take the 2 from here and the 8 from here, and we're going to multiply those two together to get 16. We're going to take the x to the power of 3 and the x to the power of 4, and we're going to add those exponents so that we get, you see, x to the power of 7. So now we have 16 to x to the power of 7. This, boys and girls, is pre-algebra. Here we have the same concept. Now we're multiplying a negative times a positive, so you know you're going to have a negative answer, right? And now you're working with a negative exponent, so you know that this is a fraction, okay? And you're going to add a negative exponent with a positive, so that you know right here you're going to have negative 1, right? You have negative 1 left over, as you can see right there. And then you know that you can either write it this way, 6n, okay, because you multiplied 2 times 3, as you can see right there, right? Negative 3 times 2. And now you have what you can say is negative 6n to the power of negative 1, or you can write it as a fraction, okay? But notice how it's written as a fraction. It's no longer over 1, okay? The n is the one that has the exponent. So the n, if it were to be written by itself, it would be n to the power of 1, or we just say 1 over n. But we don't have a value of 1. It's not n by itself. We actually have a value of 6. So we must write 6. You see that? Oh, it's negative 2, as you can see right there, boys and girls. Okay, so for A, let's use the multiplicative property. The commutative property. Okay, the commutative property. And let's group the numbers with numbers and variables with variables, okay? What I want you to do is go ahead, pause the video and try these 4, and then play the video again to check your answers. Pause now. Here's what I have written down for A so far. 5 times negative 3 times A 2 plus 4, the exponents, as you see right there, okay? And when I calculate, I have a negative number here because it's positive times negative. 5 times negative 3 is negative 15. A to the power of 6. Okay, now let's try 3b, where I have 6b to the exponent of negative 4 times 2b squared. We're going to use commutative property, where I'm going to multiply 6 times 2, and I have 12b, and now I'm going to add negative 4 plus 2. It's going to make it negative 2, right? But this is not my final answer. My final answer, I want to get rid of the negative exponent, so I will write it as 12 over b squared. 3c, we have 6 times negative 3, which would be negative 18, x to the power of 8, okay? Because we add the exponents. And using commutative property again, we have 10 times 5 equals 50, n to the power of 9, because again we add the exponents. Now we're going to divide powers. So divide powers with the same base by subtracting their exponents. So now instead of adding the exponents, when we divide, we subtract, as you can see right there, we subtract their exponent. Okay, take a look at the example where we have 3 to the power of 6 divided by 3 to the power of 2, which is going to subtract the exponents, and we get 3 to the power of 4. On the next page, you'll see the explanation of why we subtract. When we have 4 to the power of 5, we have 5 fours right there, 5 factors. And over here we have 2 factors, and when we divide, we're dividing these two, so it takes away 2 of them. You can see they cancel each other out, so we're only left with 3. Okay? Also take a look at the example here on your own, how we use numbers and variables as well. Okay? Let's try for A to D. Keep in mind that we are subtracting now, and we have the same base. So I have a base of 3, and now we have 9 minus 2 equals 7. Okay? Next we have a base of B, okay? And 7 minus 6 is B to the power of 1, or we can just simply write B. Next we have to the power of 5, and we have 4 divided by 4 to the power of negative 2. Now we're subtracting a negative. Minus minus. It's like writing this, boys and girls. It's like writing, I'm only going to write the exponent. It's like writing exponent 5 minus 2. You know that when we take away a negative, we're actually adding positives. We're taking away negatives, so we're allowing the positive to grow by the amount of 2. So it should be 4 to the power of 7. Okay? And now we have our base of a, and we have negative 4 minus 1. When you have negative 4 minus 1, you're going to have negative 5, right? Because again, it's like writing 4 minus 1. How many negatives do you have in total? You have negative 5 in total. Okay, but we're not done. We can't just leave it like that. So we must write it as 1/5 to the power of 5 as a fraction. I'm sorry, I got confused. I thought this was a 5. It's actually an S. So this is an S, and this is an S. I'm sorry, I think I need glasses. Now let's look at the word problem. Remember that we use exponents to express very large numbers. Okay, so here 2 to the power of 12. It's 2. You multiply it into itself 12 times. Okay, as you can see right there. And then we have 2 to the power of 13. It's 2 multiplied into itself 13 times, and 2 multiplied into itself 15 times. Okay, and this is the approximate diameter. Diameter is the distance across the circle. So if you have a circle, the diameter is the line that cuts it in half all the way across. I like to remember it by remembering the distance. Distance, di, the distance across. The table shows the approximate diameters of Earth, Mars, and Neptune. About how many times as great is Neptune's diameter than Earth's diameter? Okay, so we're looking for how many times greater is Neptune than Earth. Well, we see that we have 2 extra powers, right? So what we do is we want to divide the larger amount by the smaller amount so that we can figure out how much bigger Neptune is. As you can see right there, we're dividing 2 to the power of 15 divided by 2 to the power of 13. We subtract the exponents and we get 2 to the power of 4, or simplified is 4 times larger. Therefore, Neptune's diameter is about 4 times as great as Earth's diameter. Okay, let's try 5a and b. About how many times as great is the diameter of Earth than the diameter of Mars? So we're looking how much bigger Earth is than Mars. So we take Earth and we place it at 2 to the power of 13 over 2 to the power of 12. And when we subtract it, we get 2 to the power of 1, or just 2. So it's 2 times greater. As a key answer, you will write 2 times greater, which is our regular, therefore it's 2 times greater, but I also want you to add this sentence in Spanish. El diámetro de la Tierra es 2 veces mayor que el de Marte. This is your key answer, a Spanish sentence. 5b. The diameter of a small asteroid is 10 to the negative 1, to the power of negative 1 kilometers. The diameter of Ceres is 10 to the power of 3 kilometers. About how many times as great is the diameter of Ceres than the diameter of the small asteroid? So again, we take the larger amount, so Ceres is 10 to the power of 3, and we're going to divide it by the smaller amount, 10 to the power of negative 1, so that we can figure out how many of these are in here, and that's our answer. So same thing, we have our 10 is our base, and we're going to subtract a negative. So it's 3 minus 1. When you subtract a negative, you're actually adding 1. So it's going to be 10 to the power of 4. Therefore, Ceres is 10,000 times larger. Notice that I took my 10 to the power of 4 and converted it into a regular number, into a natural number of 10,000. 10 to the power of 4 means it has 4 zeros, 1, 2, 3, 4. Please leave the guided practice for class so we can do it together as a warm-up. But please complete all the questions in the independent practice from 19 to 44. You only have to do this section. The rest we will do in class. So 45 and beyond we'll do in class. We'll have plenty of time to do this. Okay, see you in class, everyone.